Hello NEET aspirant. This is our second lecture, and in this lecture we are going to discuss PYQ, previous year questions, which is related to motion in a straight line chapter 2. Okay, but before starting answering the question, let me finish something that are quite necessary to uh, solve these problem that comes in this chapter. Okay, so let's start. First of all, you have to know the basic idea of differentiation. Differentiation, that is, for example, let's say if a particle is displaced and say displacement is x is displacement, and for that displacement, let's say the velocity of that particle is dxy dt. It means with respect to time, differentiation of x is velocity. Actually, we all are known that velocity is equal to distance upon time, or change in distance upon change in time, that is velocity. So you have to know this. And again, for acceleration, a becomes dv by dt. It means velocity with respect to time is acceleration. Okay, now some questions are related to integration part. For example, if velocity is given and you have to calculate the displacement, then dx becomes v into dt. And for this part we have to solve integration, that is integration dx becomes integration v dt. And in those questions, they've given us the velocity and ask us to count the displacement. Okay, now let's see another part, which is equation of motion. Equation of motion, and these are pretty important for our problems that are comes from these chapter. So first one is v equals to u plus at. It means final velocity becomes initial velocity plus acceleration into time. Second is displacement s becomes ut plus half at square. And third one becomes v square is equals to u square plus 2as. So I hope you get my point, that these are some necessary formulas you have to remember. It means necessary, not necessary, but must formulas. Must to be remember. Must to be remember. Now, before further delay, let's solve our previous year questions from chapter 2, that is motion in straight line. Okay, so question number 1 is the position of a particle is given by this. Position of a particle is given by rt equal to 40 plus 2t square plus 5k. It means it is a vector notation. R, that is depends upon t. It means variable of t is equal to 40 I cap plus 2t square j cap plus 5 k cap. Let's read further, where t is in second and r in meter. Okay, so time is in second and uh, displacement r is in meter. Okay, let's see. We have to find the magnitude and direction of velocity at t equals to 1 second with respect to, and direction with respect to x axis. So let's see. Velocity becomes dr by dt. That is our common formula. In our formula I teach you r is actually x. Okay, time dependent quantity, right? Let's see. V at time becomes d by dt and r 40 I cap plus 2t square j cap plus 5 k cap. Okay, let's see. I am assuming here that you are familiar to the differentiation, and so I am writing directly 4 I cap plus 2 into 2, that is 4 j cap plus 0 k cap, because here no quantity involves t. Okay, so 4t, sorry, 4t j cap. So here we have to count at time t is equal to 1 second. Okay, so at t equals to 1 second, equals to 1 second, v becomes v at 1 second becomes 4 I cap plus 4 into 1 j cap, that is 4 I cap plus 4 j cap. But this is in vector form. This is in vector form. So we have to calculate the magnitude, v magnitude, that is equals to under root square of this one plus square of this one. Coefficients square, 4 square, that is under root 32 and may be written as 4 root 2. Okay, 4 root 2 meter per second. Let's see from options. There are 3 options involving 4 root 2, 4 root 2, and 2 options 3 root 2, 3 root 2. So we have to calculate direction also. For direction part, we have to just count 10 alpha, 10 alpha, and alpha is direction. So 10 alpha become, it is quite easily to be calculated. Tan alpha becomes coefficient of this part divided by coefficient of this part. It means coefficient of I divided by coefficient of j, 4 upon 4, 4 upon 4, and it becomes 1. And 1 is the value of tan 45 degree, and alpha becomes 45 degree. So V becomes 4 root 2, and alpha becomes 45. 4 root 2, alpha becomes 4 root 5. So next question is, a vehicle travels half the distance with speed v and remaining distance with speed 2v. Its average speed is. So for average speed, you have to just remember the formula, which is in parallel combination of resistance. Same formula, parallel combination of resistance, and that is v average equals to v1 v2 upon v1 plus v2. Just put the value and let's see, v into 2v upon v plus 2v. So it becomes twice v square upon 3v. v2 we cancel and it becomes 2v by 3. So 2v by 3 is correct answer. Okay, let's see. Next question. A horizontal bridge is built across a river. A student standing on the bridge throws a small ball vertically upward with a velocity 4 meter per second. The ball strikes the water surface after 4 seconds. Height of the bridge above water surface is, take G as this one. Let's see. A student, a bridge is this. He is standing right here and throw a ball. Let's see, he throw a ball like this, and this is the surface of river. So we have to count the height of bridge above water surface. It means we have to count the height of this way. So he throws at velocity v equals to 4 meter per second. Sorry, v naught, it is actually u equals to, because it is initial velocity, and g is this one. So from second equation, displacement s equals to ut plus half at square. Let's sort out some confusion here. So if we throw something upward or downward, it means if we throw something vertically upward or from some height to on the earth surface or some water surface, then gravity acts as minus g. It means a equals to minus g. Okay, free fall condition. And s is h equals to u. U is 4 into time 4 second plus half minus g. It means minus 10 into 4 4 16 2 5, and it becomes h equals to 16 minus 16 5 80, and it becomes 64 meter. Okay, let's see. Next question is, the displacement time graphs of two moving particles makes angle of 30 degree and 45 degree with x-axis as shown in figure, ratio of their respective velocity. So let's see, this is displacement for this and displacement for this, time for this, time for this. It means 30, this is for 30 and this is for 45. So we are known this v equals to x upon t, means displacement upon time. Okay, let's see. But no value is given here, only angle is given here. So for angle, v becomes let's see, ratio. So ratio becomes tan 30 for 30 degree and divide by tan 45 degree. Why we take it like here? Let's see. Look at here. Actually, for tan theta, this is perpendicular upon base. Okay, perpendicular upon base. So tan 30, that is 1 by root 3, and tan 45 1. So the ratio becomes 1:3. Okay, so fourth answer is correct. Let's see. A ball is thrown vertically downward with a velocity of 20 meter per second from the top of a tower. It hits the ground after some time with a velocity of 80 meter per second. Height of tower is, so let's see. Here is a building or say tower. Height, assume h. A ball is thrown from 20 meter per second. G is acting downward and it hits ground. It hits ground at velocity 80 meter per second. So let's see from equation number third, v square is equals to u square plus 2a s. In our case, it becomes v square minus u square is equals to 2a h or 2g h. Okay, so v square minus u square upon 2g is equals to h. Okay, let's put down the value. H becomes v square, that is 80 square minus 20 square initial velocity upon 2 into 10 z. Okay, so h becomes 6400 minus 400 upon 20, and it becomes 6000 upon 20. Cancel out 10 to 10, h becomes 300 meter. So the height of tower is 300 meter, this height. Okay, now move to the next question. Next question is, if the velocity of a particle is v is equals to at plus vt square, a and b are constant, then the distance traveled by between 1 second and 2 second is. Okay, so velocity is at plus vt square, and we know that velocity v becomes ds by dt. So in this, ds becomes v into dt, and we have to calculate the distance traveled. It means ds is v into dt. Integration 0 to s, limit for displacement, and for time it is 1 second to 2 second. Let's put down the value. It becomes s is equals to integration 1 to 2, and it is v is how much? At plus bt square. At plus bt square into dt. So again, I am assuming that you are well aware about simple integration 1 to 2 at dt plus 1 to 2 bt square dt. Okay, let's see. S becomes at square upon 2, 1 to 2 limit, plus bt square upon bt की power 3 upon 3. Okay, 1 to 2. So put down the value of limit, and s becomes a 4 by 2 minus 1 by 2. Okay, and this becomes b 8 by 3 minus 1 by 3. Okay, so for conjugation, let's see how much it comes out. So s becomes how much? A 3 by 3 from this factor, and plus b 7 by 3. Actually it is 3 by 2 and 7 by 3. A is 3 by 2 and b is 7 by 3. Actually this is correct, option D. Let's move to the next question. The motion of a particle along a straight line is described by the equation. Equation is x equal to 8 plus 12t minus t to the power 3, where x is in meter and t is in time. Second, the retardation of particle when its velocity becomes 0. So two conditions. First we have to put the velocity 0, and then we have to find the retardation, which is negative acceleration. Okay, let's solve. X is this one, then v is dx by dt, and how much it comes out? Dx by dt, it is 8 plus 12t minus t to the power 3. Okay, so b becomes one second. B becomes 0 plus 12 minus 3t square, and we have to know that for velocity 0, it means this value should be 0. Okay, so 12 becomes 3t square, and t becomes 4. Sorry, t square becomes 4 and t becomes 2 second. Okay, so time is here, velocity is right here, this value. Now we have to just find out the acceleration, and for this, acceleration becomes 1 minute. Acceleration becomes dv by dt, and d by dt for velocity, the value is 12 minus 3t square. Okay, so it comes out 0 minus 6t, and a becomes minus 60, and the value of t is minus 6 into 2, and a becomes minus 12 meter per second. Okay, so right here minus 12 meter per second square. Actually minus is not given here because it is retardation. Okay, so it is conventional that retardation is negative acceleration. Now move to the next question. A boy is standing at the top of a tower of 20-meter height, drops a stone, assuming g is 10 meter per second square, the velocity with which it hits the ground. So you have to count the velocity. Okay, so let's see. A boy again is standing at a tower, 20-meter height, 20 meter. Okay, and g is something which hit the ground. It means velocity of v we have to count, and u is 0. Drop a stone, it means free fall. He doesn't apply any force, it means the initial velocity should be 0. So v square is equals to u square plus 2a s or h. In our case it becomes h. Okay, so v square we have to count 0 plus 2gh. Okay, so v square becomes 2 into 10 into 20, and it becomes v square becomes 400, and v becomes 20 meter per second. Okay, so v is 20 meter per second. Right, now next question. Let's see. A particle moves in a straight line with a constant acceleration. Acceleration is constant. Okay, it changes velocity from 10 meter per second square to 20 meter per second. Now, while passing through a distance, this one in t second, value of t is okay. So let's see. U is given 10 meter per second. Initial velocity, final velocity is 20 meter per second. Acceleration is constant but not given to us. Okay, question mark. Time we have to count, and distance we have to given 135 meter. Okay, let's see. So first of all, apply equation third, that is v square equals to u square plus 2as. We have to count a, so 2as becomes v square minus u square, and s becomes v square minus u square upon 2a. Sorry, a becomes v square minus u square upon 2s. Some mess up here. Okay, let's see. 2s. Just put down the value, and it becomes v is 20. So 20 whole square minus 10 whole square upon 2 into 135. Okay, so let's see. A becomes 400 minus 100 upon 2 into 135. Okay, so right here it comes out 300 upon 135 into 2. So I think I mess up something or not, maybe. So it becomes 150, and a becomes 150 upon 135. So from 15 table it becomes 10 by 9. Okay, 10 by 9 meter per second square. So in our question it is not necessary to count a, actually it is necessary to count time. So now v is equals to u plus 80. All the values are available, so t becomes v minus u upon a. Okay, so v is how much? V is 20, a is 10. Okay, v is 20 minus u is 10 upon 10 upon 9. So t becomes how much? 10 into 9 upon 10. 10 to 10 cancel out, and it becomes 9 seconds. So let's see, 9 second value of time. So this lecture is over here. Let's hope we meet in new lecture, next chapter, I mean